In math class, X is usually used for the unknown. Physicists and astronomers, however, usually use other letters to stand for the quantities they are interested in. For example, F represents a force typically, A is acceleration, D stands for distance, M is mass, and so on. If we used X for everything, it would get very confusing. Don't let the fact that we're not using X like you do in math class confuse you. What letter is used doesn't matter. The word equation means that you have two things equal to each other. To signify that, we put an equal sign between them. This may sound like I'm talking down to you, but I do want to stress that an equal sign is a very strong statement. The two sides of the equation are the same. They are interchangeable. The phrase, solve the equation, means to arrange the parts of the equation to isolate, to get by itself, that one variable that you're interested in knowing. Let's do a specific example. The equation F equals ma. This is Newton's second law. Force equals mass times acceleration. But at this point, it's just letters and we're just talking about algebra. We don't even have to talk about the physics. And let's say that we want to know the acceleration, an equation for the acceleration. We want a by itself. And it can be by itself either on the left side or the right side of the equation. It doesn't matter. And the easiest way to do this is to get rid of the m, the mass, because it's multiplying the a. But we can't just erase the mass. If we did that, the equal sign would no longer be true. So we can't just get rid of the mass. So what can we do? Here's the way you should reason it out. What is the m doing to the a? It's multiplying it. So to get rid of that multiplication, we need to undo the multiplication. We need to do the opposite. What's the opposite of multiplying? Right, dividing. So divide both sides of the equation by the mass, m. We have to do it to both sides of the equation because that keeps the equal sign true. If two things start out the same, and then you divide both by the same number, they remain equal to each other. Doing this, we get f over m is equal to m times a over m. We have m over m over m is equal to 1. And 1 times a is just a. We like to say that the m's cancel, although math teachers don't really like that terminology. It's a convenient shorthand for saying that the m over m equals 1, and 1 times a we can just say is a. We can ignore the m's. So, in a sense, they just go away. And we're done. We now have f over m is equal to a, or we can turn it around if we prefer and write a is f over m. The method described above is completely general. Whatever operation, things like multiplication, division, addition, etc., are happening to the thing you're trying to isolate, you need to undo them by doing the opposite or inverse operation. Addition and subtraction are inverse operations. Multiplication and division are inverse operations. Raising a number to a power is the inverse operation of taking the root. Let's look at another example. Here's an equation, d equals 1/2 at squared. Again, for right now, we don't really need to know what these represent, but if you're curious, the d is distance, the a is acceleration, the t is time, and this describes the distance that a moving object will move if it starts at rest with a constant acceleration. Let's say you want to isolate the t. For instance, you wanted to know how much time it takes a ball to drop a certain distance when you know the acceleration due to gravity. So we want to get t by itself. Well, what's happening to the t? It's being multiplied by 1/2, and it's being multiplied by a. So it is also being squared. Now, the thing about reversing the operations is you have to undo them in the reverse order in which they happen. Do you remember your order of operations? Often it's taught using the mnemonic device PEMDAS, parentheses, exponentiation, multiplication and division, addition and subtraction. What's happening here to the t first is it's being squared, and then it's being multiplied by a and multiplied by 1/2. So, in other words, this is not 1/2 a t squared. The square only applies to the t. So we need to undo the things that are happening to the t in reverse order. The t squared is being multiplied by 1/2. So how do we undo multiplying by 1/2? You can multiply by 2, but you have to do it on both sides. The 2 cancels the 1/2, because 1/2 times 2 is equal to 1, and we can ignore the 1. What else is happening to the t squared? It's being multiplied by a. How do you undo multiplication by a? You divide by a, but you have to do it to both sides. The a is canceled, because a over a is equal to 1. And lastly, we have t squared is equal to 2d over a. How do we undo that squaring? We take the square root of both sides. Now, it's gotten a little messy here, so I'm going to clean it up a little bit. I'm going to write square root of 2d over a is equal to the square root of t squared is equal to t. Or if you prefer your unknown variable on the left-hand side, as we often do, we can just flip it around. T is equal to the square root of 2d over a. Let's do one more example, and we'll make this one even more challenging. This is the equation for the force of gravity, as figured out by Sir Isaac Newton in the 17th century. F is equal to g times m1 times m2 over r squared. Force of gravity is equal to a constant, this big G is a number, times the masses of two objects that are pulling on each other by gravity, divided by the distance between them, r squared. And let's say that we want to solve for r. In this case, it's a little more complicated because the r squared, is in the bottom of a fraction. So when we say we want to isolate it, we want to make sure that it's not isolated in the denominator, in the bottom of a fraction. So the first thing we're going to do is we're going to multiply both sides by r squared. And that gets the r squared out of the basement, out of the denominator. And now we have r squared times f is equal to big G times m1 times m2. And so now, with the r on top of the fraction, keep in mind just a number by itself means it's in the numerator of a fraction with a 1 on the bottom if you need to write it as a fraction. With r on top of the fraction, we say what's happening to the r, and in what order. The r is being squared, and it's being multiplied by f. So we need to undo those operations in reverse order. Let's get rid of the f, and then we'll get rid of the square. How do we get rid of multiplying by f? We divide both sides by f. F over f cancels, and now we have r squared is equal to g m1 m2 over f. How do we get rid of the square? We take the square root of both sides. Again, it looks a bit messy because I've done all the steps on top of each other, but let's go ahead and write it out nice and neat for our final result. The square root of r squared is r is equal to the square root of big G m1 m2 over f. Keep in mind that square root covers this entire thing. G m1 m2 over f is all under the square root sign.